Hello guys, welcome to Simplify Your Concept. Today we are going to start with a very interesting topic that is single phase transformer, and this is the first video on it.
So we are going to start the session with the introduction, followed by why do we need a transformer? Then we shall see the construction and working principle of transformer, followed by the classification of transformer. Then we will also derive the EMF equation of transformer. We shall also see the losses in the transformer, how to calculate the efficiency of a transformer, and then finally we will see the condition for maximum efficiency. So let us start the video with the introduction. So first we should understand what is basically a transformer is and what the function it performs. So transformer is basically a static or a stationary electrical device. Now why the transformer is called as static device? Because as we know that the transformer basically works on the principle of Faraday's law of electromagnetic induction. And the EMF which is induced in the transformer is static in nature. So that is why the transformer is also called as a static electrical device. At the same time, it is also called as a stationary electrical device because in the transformer there is no rotating parts. All the components in the transformer are stationary. Hence, it is called as a stationary electrical device. So this is a transformer, and what are the function it performs? So the first one, if we say the transformer basically transfers the electrical power from one electrical circuit to another. So the basic function of the transformer is to just transmit or to transfer the power from one circuit to another circuit. But how does this happen? So the transformer does this by increasing or decreasing the voltages. The transformer which were called as step up or step down transformer. So basically the stepped up transformers will increase the voltage level. At the same time, a step up transformer will decrease the current level. Why it happens? Because the power on both the sides of the electrical circuit does not change. So it just has to transfer the power from one electrical to the another electrical circuit. Similarly, a step-down transformer will decrease the voltage level and at the same time it will increase the voltage current level so that the power on both the sides of the electrical circuit does not change. Also, the transformer does not change the frequency. That means the power which is being transmitted the transferred from one circuit to another circuit, this happens without the changing in the frequency. So these are the function of the transformer. Now let us see why do we need a transformer. So we know that one of the major reason for utilizing of electricity in AC form is because the transformer can work on AC supply. Now let us try to understand why there is a transformer so much highly recommended or highly utilized in electrical power system. Now if we see here, this is a structure of the power system which is given here. This is the generation or the generating station. Here this part is the basically the distribution or we say utilization, or we also call it as load centers. And in between we have the transmission system. So this part is the transmission system. So basically any power system is classified majorly into three major parts. One is the generation, then the transmission, and finally the distribution of electrical power. Now, if we say here that power station could be any power station, it could be hydro, thermal, nuclear, and so on. So the voltages which is being generated at the generating stations are of the order of somewhere 11 kilovolts to 33 kilovolts. That is what is the voltage which is generated. Whereas if we talk about the load centers, where we basically utilize the power, we hardly need say single phase 230 volts, or some industries may also need three phase 11 kilovolts. So When the voltage is generated at 11 kilovolts, if we try to transmit the power with the same voltage, there will be huge transmission line losses. So in order to avoid these transmission losses, the best practice is to increase the voltage level and then transmit the power at the higher voltage levels. So how can we increase these voltage level? With the help of step-up transformers. So if we see here, after the generating station, we are using a step-up transformer, which is stepping up this 11 kilovolts or 33 kilovolts to a higher voltage level, which is the 132 kilovolts or 220 or even 400 kilovolts. So now the power is going to be transmitted at this high voltage. And because of this high voltage, what happens? The losses will decrease. So if we increase the voltage, the losses in the transmission line can be reduced. Now this power will be transmitted through the transmission lines, and further when this reaches to the sub-transmission system, see, the complete transmission system is actually divided into two parts: transmission and sub-transmission, because generally the load centers are very far from the generating stations. So the power has to be transmitted through the transmission line, but the requirement for the distribution load is very less. The voltage levels required are less. So the high voltage which is being utilized for the transmission has to be slowly stepped down for the requirement of the load. So this transmission line, which was carrying a voltage of around 400 kilovolts, will again step down this voltage level with the help of a step down transformer to, let's say here, 66 kilovolts. And then further through the sub-transmission system, the power will be transmitted at this particular voltage. Now again, we do not need this much high voltage. So further in the distribution substation or in the distribution system, this voltage will further be stepped down with the help of another step down transformer to say around 11 kilovolts or 33 kilovolts. Now in case if an industry needs this much voltage, it can directly take it from the distribution substation, the required amount of voltage. Whereas if we talk about a domestic home, we hardly need 230 volt single phase. So further, this 11 kilovolts has to be stepped down to around 230 volts if we are talking about a single phase system. And then single phase voltage, which is around 230 volt, will be utilized in a domestic application. So as we see here that the transformer is one of the most important part in every sector of the power system, including generation, transmission, distribution, and utilization of electrical energy. And this transmission can happen with varying the voltage levels at different stages. So basically we know that after the generation, when the transmission has to be done, we need to go for higher voltages in order to reduce the losses, and for this we basically require a step-up transformer. Whereas in case of the distribution system, where the transmission system terminates, there the voltage has to be stepped down or it has to be reduced. So with the help of a step-down transformer, we can obtain this. Whereas in some cases, in some stages, we also require isolation of the voltage levels. So for that, we do not go for step up or step down voltage. Instead, we use just one-to-one or isolation transformers. So this explains why the transformers are so much utilized in the electrical power system. Now this is the figure which represents a step up and step down transformer. Later we will explain all this. So here just look at the number of turns. So if you see here, these are the primary windings or primary coils. Similarly, this is the secondary coils. So here the primary number of turns, if I say N1, and secondary number of turns if I say N2, and if N2 is greater than N1, I'm going to get a step up transformer. Whereas here, if we see that N1 is greater than N2, so we say that we are going to get a step down transformer. So you can see here the voltage is from 110, it has been step up to 220 volts, whereas here the 220 volt has been stepped down to 110 volts. So this just give a picture about how a step up transformer and step down transformer looks like. Now let us start with the construction of transformer. So we know that basically a transformer has two major parts in it. One is the magnetic core and the second one is the windings of the transformer, or they are also called as the coils of the transformer. So this part, if we see this solid part, if we observe, this is the magnetic core. And this magnetic core is generally made up of laminated sheets of steel. We can also use iron, or we can use high graded silicon steel as a material to make this core. Now we are using thin laminations here, and these are the different shapes of laminations which we can observe. So E shape, I shape, or L shape, U and I shape, various types of laminations can be used, and all the thin laminations are used together and then they are stamped together to form this magnetic core. Now the function of this core is basically to provide low reluctance magnetic path for the flow of flux. So since this is a magnetic core, a magnetic component which is called flux will flow in this core. And this magnetic core will provide a low reluctance path for this flux to flow in this entire path. So that is about the magnetic core. The another most important part of the transformer is the windings. So we know that basically the transformer has two inductive windings. One is the primary winding and the other one is called as the secondary winding. The winding which is connected to the source, okay, it is called as the primary winding, and the winding which is connected to the load side is called as the secondary winding. So the material which is used to make these windings could be generally copper or even aluminium can be used. What is the function of the windings? It basically carries the primary and the secondary currents. All right. Now I have written here saying that the two windings are inductive in nature. The meaning of inductive winding means they are not directly connected with each other, or we say there is no electrical connection between these two windings since they are placed on the same magnetic core. So we say that these two windings are inductively coupled. That is why we call these windings as inductive windings. So here the laminations of the core are shown here. So this is a single laminated lamination which is of the form of a rectangular, and n number of laminations are taken together and then they are stamped together to form the laminated core. So if we use a solid material to make the core, the losses in the core will increase. And if we go for laminated core, the losses in the core of the transformer will reduce. So here we can see there is different shape of laminations are used, E and I shape here. And here some of the manufacturing of the core is taking place where they have used thin laminations. You can see here thin laminations are used and then it will be stamped together to form this entire core. So that's all for this today's session. In the next session, we will see the working principle of the transformer. Thank you so much for watching.